Hello everyone, welcome to MicroSAM. In this tutorial video, we'll be learning about how to use the 2D annotator and the features like interactive and automatic segmentation in Napari using the MicroSAM tool. Okay, so the first thing what we do is activate our pre-installed environment. If you haven't watched the video of installation, we highly recommend watching our quick start video. Then we go ahead and open Napari. And there we go. We have our GUI interface activated over here. Let's go ahead to plugins, segment anything for microscopy and the 2D annotator. Let's go ahead and open a sample image. And drop this at the end of the layer list. Now let's try to understand the widget options in the annotator 2D. The first console computes the image embeddings. The next console makes the choice of the positive or negative point prompts. The next console allows you for prompt-based segmentation, and you can choose the batch segmentation if you want to segment multiple objects. The next is the automatic segmentation console for running automatic segmentation. There is a choice for changing the automatic segmentation settings. The next console is for committing or saving the objects once you have segmented them. And the final console is for clearing the undesired prompts and segmentations. This is the region where the image stays open. And these are the list of layers. The first one is committed objects, which stores the confident segmentations. The next is the automatic segmentation layer, which stores the automatic segmentation. The current object layer for storing the currently prompted segmentations. The prompts layer, which stores the box prompts. The point prompts layer, which stores the point prompts. Okay, so let's open the segment anything models. Let's get started with computing the image embeddings. We first make the model choice. Over here, the acronyms VITT, B, L, and H denote the default segment anything models, with T being the most resource efficient and H being the most resource expensive. And this affects the segmentation quality to some extent. The acronyms at the end LM specify the generalist models for the light microscopy domain, and the acronyms at the end with EM organelles specifies the models for the electron microscopy domain for mitochondria and nuclei segmentation. Now let's go ahead and choose VIT base model and compute the image embeddings. We see the progress bar on the bottom right, which shows how much time it takes to compute the image embeddings. For 2D images, it's often a few seconds. Now let's go ahead and perform automatic mask generation with the default segment anything model. The progress bar indicates how much time the automatic mask generation would take. In this case, the automatic mask generation often takes a couple of minutes. And there we go. We have our segmentations obtained. We instantly observe some missed segmentations, some incorrect segmentations. Let's go ahead and rectify them. The first thing what we do is choose the pick mode to choose the background to eliminate the wrongly segmented objects with the fill mode, and there we go. And with a few clicks, you can quickly remove them. We also observed that there are some larger structures which were incorrectly segmented. Let's go ahead and remove those segmentations. One of the other structures as well, and another background which we missed. We would use prompt-based segmentations to add segmentations for these missed out objects. Let's go to the layers and switch to the automatic segmentation layer, as that's the layer we would want to commit, which is storing the confidently segmented objects. There we go. All of these objects are now stored in the committed objects layer. Let's switch back to current object. Let's go to prompts and choose the box prompts first. Now we segment the missed out objects using box and point prompts. Let's start with box prompts. Let's go ahead and choose an object to place a box prompt around. Once we have done, let's go ahead and segment the object. And there we go. The object has been segmented. However, there were some artifacts which were picked around. For this tutorial, we will focus on the workflow. For a better segmentation quality, we recommend using the generalist models for the particular domain, which we will look into later in this video. Let's go ahead and commit our segmented object using the commit console. Now let's say we are satisfied about our current segmentation. Let's go ahead and save them using the commit option in the current object layer. And there we go. These prompt-based segmentations have now been stored. Let's switch to point prompts and make the choice of the positive prompt. Let's insert the point prompt to an object and segment the object. As we see, the object wasn't segmented as we desired. Let's go ahead and put a negative prompt outside the object. You can choose the T key binding from your keyboard to switch between the positive and negative point prompts, and you can press the S key binding to segment the object, and then segment the object again, and there we go. Now the object has been segmented roughly as we desire. Let's say we are satisfied with our segmentation. Let's go ahead and commit the segmentation. Let's try a positive prompt again. Let's segment the object, and there we go. Let's say for now we are confident about our segmentation. Let's go ahead and commit this object. Now let's use a different kind of prompt for longer structures like one of these. So we go to prompts and select the polygon lasso tool. Let's draw a freehand polygon roughly around the object. And let's go ahead and segment the current object. And there we go. We see that the object has been roughly segmented as we desired. Let's go ahead and commit the currently segmented object. Next, we see how we combine multiple prompts for segmenting the objects. Namely, box and point prompts and multiple point prompts. So let's start with the box prompt. We place it around our object of interest and segment it. We see that the segmentation did take place, but it wasn't of as desired quality. Let's go ahead and put a negative prompt outside the object. We see that there was some improvement, but it did pick up some artifacts. Let's go ahead and put another negative prompt. Let's say we are satisfied with our segmentation. Let's go ahead and commit the segmentation. Now let's go ahead and use point prompts for segmenting another object. So we use the positive prompt inside the object and we see that the segmentation quality wasn't as desired. We place a negative prompt outside the object and we see that the segmentation is a bit better. Let's improve it by further negative points. Let's say we are satisfied with our segmentation. Let's go ahead and commit the segmentation. And there we go. Now for the next part, we learn about how we can segment multiple objects at the same time. Let's go ahead and place multiple box prompts around multiple objects. And let's press segment object. And there we go. All the objects were individually segmented. The segmentation quality is not as desired, and for some of them, it's roughly as we expect. Let's say we are satisfied with our segmentation. Let's go ahead and commit the segmentation. For the next part, we use multiple point prompts to segment the objects. Let's switch batched to on. In this mode, each positive prompt will lead to individually segmented objects, and you can use negative prompts which will be shared across all the other objects in the batch. And let's place multiple point prompts across different objects we desire to segment. We observe that the segmentations are not as we desired because segment anything model has never looked at the microscopy domain. Let's limit ourselves to a few objects to understand the behavior a bit better, and there we go. The segmentations did take place, the quality isn't as we desired, but for the known reasons that the model has never seen this domain. Let's go ahead and commit these objects, and there we go. Once we are satisfied about our segmentations and we have committed them, let's go to the committed objects layer, go to save selected layer, and this is how you can save your segmentations. We will be showing one of these demos later in the video with a better model. Now, let's choose a model from the light microscopy domain, which is supported by MicroSAM. We have used the default segment anything model so far, and as we observe that segmenting the full image with it would be quite tedious. So instead, we now use one of our models that was explicitly trained for microscopy to provide a better segmentation experience. Let's go ahead and compute the image embeddings. We see over here that all the layers have been cleaned up for us for a fresh start. Now let's wait for a few seconds. Our embeddings have been computed. Now let's go ahead and make the automatic segmentation. This uses the automatic instance segmentation feature from MicroSAM. The automatic instance segmentation method uses a different logic for automatic segmentation compared to the default segment anything models. and is much faster with better segmentation quality. This feature is only available for our MicroSAM models. And as we see over here, we get high quality segmentations in a very few seconds. However, there could often be cases where the objects are over segmented or not segmented as we desire them. One of these objects is this. Another one of the objects which was missed from the segmentation. And here is another object which wasn't segmented as we desire. And some objects pick up some artifacts. Let's go ahead and fix them. So the first thing we do is choose the pick mode and then remove the objects which we do not desire to have. Let's choose the pick mode and the fill mode to cover the artifacts. And for the last case, wherein the objects were over segmented, let's choose the pick mode for one object, fill up the artifacts, and then merge the over segmentations. And this is how we can rectify with a few clicks very quickly. Let's say we are confident about our segmentations. Let's go to the auto segmentation layer and commit our objects which were segmented using automatic instance segmentation. They are stored in the committed objects layer now. Now let's start segmenting the objects using interactive segmentation. Let's choose the box prompt first and segment this object in the corner. Let's go ahead and segment this. There we go. The object has been segmented as we desire. Let's switch to the current object layer and commit the object. Let's also segment one of these missing objects over here. Let's choose point prompts for this. Let's segment the object. And there we see the object has been segmented as we desire. Let's go ahead and commit the segmented object. And now we have segmentations as expected. Now, if we want to save these segmentations, let's go ahead and click on the committed objects layer, go to File, save the selected layer, choose a target directory and a file name. So we name it segmentation livecell.tiff here. Let's go ahead and save this. This was a tutorial on the 2D annotator and annotating images in 2D. Thank you so much for watching. Stay tuned for the next video on the 3D annotator.